Thanks everyone for being here. Today I'm going to introduce you the work X-Men, a mutation-based approach for the formal analysis of security ceremonies. So let's start with a bit of context. Nowadays, there is an increased number of information and communication technology systems where the security of those systems depends on the human user. At the same time, we are having a lot of reports that indicates that critical vulnerabilities are due because of the human user that fails to follow the security procedure the scientists decided to be appropriate. For example, we have a Ryanair passenger gets on wrong plane and flies to Sweden instead of France. Or let's consider the case of UK car insurance company who accidentally send a password update mail to the customer because of human error. In 2015, IBM reports said that the 95% of all successful cyber attacks is caused by human error. So what we can do for them? So state-of-the-art approaches and tools that we normally use for security protocol analysis cannot be directly employed for security ceremonies as their black and white view. In a sense that let's consider the dollar value. The dollar value is too powerful to represent what actually a human can do. So we actually define a formal approach to model human user mistake as mutation, considering three in particular: skipping one or more actions, replacing a message with another one, adding an action, and potentially their combinations. Also, we develop a prototype tool called X-Men that creates a mutated model that can be input to Tamarin. And we tested our approach to real-life case studies, such as the Oyster Ceremony and SAML-based single sign-on for Google Apps. And we found out concrete vulnerabilities. Let's consider the Oyster Ceremony. The Oyster Ceremony is a ceremony that sees a traveler, so a human traveler who touch in and out his Oyster card on the gate in and gate out reader. The gate in will save an information that we can think is a gate in ID that will be used by the gate out to calculate the right fare. This ceremony can be abstracted as two strips of a puzzle, and I will use those two strips to show you the approach that we have developed. So let's consider the strip of the human. The strip of the human is just a sequence of pieces that we can think is the step that the human has to take inside the ceremony. But the human can skip some of those steps. For example, in this case, attaching a piece sooner than it should be expected. Or the human can replace a piece or part with another one that resembles the same piece, the original piece that should be go there. Or otherwise, the human can add a piece inside the strip, and those mutations can be seen as human behaviors. For example, skipping to touch in and just touching out, or replacing some information that has to be sent in the ceremony, or adding one or more steps inside the ceremony. But this is not enough, because we need to consider also the other strip that presents the other agents. So in our approach, we take into account the human strip and we create mutations. Once we have done that, we need to consider also the other strip that represent the other agents and match the human mutation on the other agents. Once we have done that, is not enough. We need also to propagate all the mutations to the other parts of the ceremony, and in the phase that we call the propagation phase. The X-Men tool is capable to do all of this. We move this approach on a lower level, considering the raw scripts as you can see here. And For example, if I consider a human that skips a step, it might be that is skipping a send of a message. This has been moved also to the multi-set rewriting system, highlighting that there are several variations of the skip mutations, such as the skip of a send, the skip of a send and after that a receive, the skip of a receive and that's it, the skip of a receive and a send after that, the skip of a receive and a send, in addition to a skip of another receive, plus all the other two mutations, so the replace mutation and the add mutation. But let me give you a practical example about it. So let's consider the generalized main ceremony for the Oyster card, for the tube. So we have the always touch in and out goal. So the human user has to always touch in and out his card. Let's apply one of our mutations. So let's apply the skip of the send mutation. So the human does not send the information of the card. What is going to happen here is that we potentially have a situation where the human does not touch in. This needs to be matched using the matching mutation algorithm, removing the message that the gate in will be used to respond to the message of the human. In addition, we need to propagate the mutation, so removing all the information that were available in the first part of the messages. Once we have done that, the result will be this ceremony where we have just a touch out phase without a touch in. We designed the X-Men tool, and you are going to see here the layout where you can upload a model and you can apply the several mutations, also combine them to create mutated models. We generate a lot of mutated models for the Oyster case study and the single sign-on case study. Roughly 100 for the Oyster case study and around 500 for the single sign-on. We discover several vulnerabilities representing two scenarios for the Oyster Ceremony, where we have an incomplete journey, as I showed you in the practical example, but also a scenario where the user touches two cards in and out, creating what we have called our card clash scenario. In the green table, you are seeing here all the mutation for the Oyster Ceremony, the skip, replace, and add, and the combination of add and replace, in addition to the mutation details, so what's happening inside the mutated model, and the high-level explanation of what we should think that is happening in the ceremony. So to conclude this presentation, our approach allows a security analyst to create a mutated model based on the human mistakes, and we are making able a security analyst to consider the shade of gray of the security ceremonies. The approach can be extended, for example, weakening some constraints, increasing and expanding the library of behavioral pattern, formalizing combination of mutations, reducing the number of the models, and link our formal analysis to mutation-based entity generating test cases. Thanks for the attention.